This podcast is sponsored by CDO Group, the industry leader providing a full range of construction and project management services. CDO Group has managed thousands of projects in all 50 states. Their group of experts provides systems, processes, and procedures to make sure that your projects turn over on time and on budget every single time. With over 24 years of experience, CDO Group is the industry's leader in construction management and general contracting services. To find them, go to cdogroup.com. Hi, and welcome to the Future of Development podcast. My name's Anthony Amunategui, and I'm here to inspire people to find amazing careers in the construction development world. If you like our podcast, please make sure you hit the subscribe button down below. If you really like our podcast, make sure you hit the little bell. Hi, welcome to the Future of Development podcast. I'm your host, Anthony Amunategui. Today, we're joined by the amazing inventor of Alice, René Morkos. René, glad to have you on the show. It is awesome to finally sit down with the maker of Real AI here. You know, you've done some great work, and I'm excited about highlighting this and having the audience check out Alice and the work you've done. So, welcome to the show.
Thanks for inviting me, Anthony. Great to be here.
You know, it is something to be said about the work that it takes to discover, to really start to break down construction projects. People have said to me 1,000 times, no way, we'll never be able to do that in construction. It's just too complicated, right? There's no way you can have a machine learning or a way to look at projects on a computer. It takes years and years of experience and the nuances of it. And now you've done it.
Yeah. If I had as they say, if I had a dime for every time I heard that, right? Well, it can't be done. It's impossible. Exactly what you're saying. I hear that like over and over and over again, right? And it's like, it's been done in every other field.
Yeah.
Right. How many times has it been like, oh, it can't be done? And it's like, well, it can't be done for manufacturing, right? It's too complicated, right? And then somebody sits there and puts a couple 100,000 hours into it and cracks it. So yeah, it's definitely doable. Right. And I think the first step in getting it done is believing it. You can do it.
Right. Standing, pulling it from there, right? You have to literally stand in, this can be done, and you're going to pull the idea towards you, right? That's what it really takes, is standing over in that area and looking at the world from, this can be done. Now you start to break it down and get into this whole idea about Alice and really get the thought about creating it. Where do you start? And first of all, how does your background relate to creating this? I'm
a construction guy, second generation civil engineer. My dad was in construction before me. When I graduated high school, he gave me a good piece of advice. He said, son, study anything you want, just don't do civil engineering. So I was a little lost with what I want to do in my life, but now you've enlightened me, sir. So, I studied civil engineering, but I used to funnily enough, I'm a professor now, but I used to cut class. I like building stuff. And what the professors didn't realize is I wouldn't go to class, but I would knock on the coolest projects in town, right, and work for free.
No, I get it. There's a classroom that you can get into, right? Sitting at a desk, Now class, right? It sounded like that in my ears. I guess it's very similar to you. Very similar. But getting out to the field where you've got something that
I was blown away. We built a column. I literally remember this thought, going home and be like, that thing didn't exist this morning. And now it does. A column. Right. And it's like, okay, well, it's not very big. It's like, yeah, but it's there.
It's there.
It's been there for a very long time, So yeah, I always got a kick out of that.
Mine was my stepfather and I were building a house. We bought a house for $900, and we fixed the roof. And he had never been in construction. I had never been. I was probably 8 years old, and I remember we tore the roof apart step by step. We took a shovel, and it was a shingle roof, and we kind of took it apart, and.
Yep.
And we kept looking at it how the layers go together and how this go. And we tried a couple things, and then we went to Home Depot, and it wasn't Home Depot back, there was some other place, but a lumber yard. And the guy told us how to do it, and we went back and did that. And I remember we fixed a roof, right? We fixed the right. I could look. There was a hole there. They had a fire in the house, and someone was heating the house with a fire in the house, and there was a fire going all the way up through it, and I remember that, there was a hole. You could see the floor from the outside. And then there wasn't one. And I thought, wow, that was cool. We actually took it apart, thought about it, and now, frankly, it did leak, and we had to go back and fix it. But we learned again. We learned, okay, it's hard to patch in the middle of a roof, a patch job, right? So we realized you had to go up a bunch more layers. But you start to learn the whys of something. And I really love that part of it. Like learning why something happens and how right, that piece you're talking about where you look at, you were part of doing it. You actually put those components together. I think that's really interesting, right? I mean, that's a part that most of us construction folks really love.
I mean, the thing that I've learned in life, like anytime you're doing something, right, you're failing, right? And it's like oftentimes the folks that kind of make fun of you when you're failing, almost 100% of the time are the folks that are sitting on the sidelines, because anybody that's trying, like to me, I've gotten used to the fact that like, if I'm not failing, it means I'm not moving, right? And so to build Alice, right, I've put 35,000 hours of my life into it.
It takes nothing has ever done it. And you're right. There's always those people that are on the sidelines, sitting in the bleachers, talking down to the people on the field, like, with some sort of their sideline wisdom. And you're like, please just get on the field and see what I do every day to go through pushing this mountain uphill, pushing this water uphill. It takes, constant, and there's kind of like constant pressure on you from those people. And you're like, it's added. They don't help much, but then there's also that part in you that says, I'm gonna show them, right? I'm gonna break this because, right? There's also a little part of me that loves the challenge of something,
Yeah, I mean, for me personally, I think that I've started to gain motivation. Like I kind of realize that if the folks that are sitting on the sidelines are telling you that it's gonna fail, you're like, oh well, at least I'm doing something, right? And the bigger and the harder it is, the more people tell you that it's impossible, it's going to fail, right? But it's also when it succeeds, everyone's like, wow, right? And the story changes. It's like, yeah, I always told you it was going to succeed, right?
So you start to get into really looking at, so you start at skipping school, you're going to construction projects, you start to get a real like for the business. How does that progress?
Yeah, so it's interesting. Like for me, the thing that I've always done is really, I like to drive the edge. I like to push the edge. I like to push the boundaries, right? And I think that's fundamentally what led me to this discovery and innovation, right? Like I remember in university, I was the guy with the big earphones, or the earring, or the colored hair, or the funny hairstyle, or whatever it was, right? But it's funny, right? Like that's basically what led me to keep. First job out of school, I went to Afghanistan, right?
Nice.
And my dad had a little business at the time, and I sort of said, no, I'm going to go to a war zone, which like every single person was like, that's a dumb idea. Why are you going to do that, right? But, I was 22. I had 114 people, 5 projects simultaneously, and I got to design, build, procure my own jobs from scratch, the whole thing, right? Which was like incredible. Right? It was incredible.
It would have taken you years in another company to do that. I mean, it would take you maybe a lifetime, but to progress up the ladder.
Oh, absolutely. And then there's certain things that you can't even do, right? Because, you can't be the city that, watches for code violations and at the same time be the architect and the structural engineer. Like there's just a conflict of interest in these things. Whereas in a place like Afghanistan, there's no one else, right? It's like you've literally got to go figure out how to do it, right? I remember calling my boss and saying like, hey, there's no steel. And he goes, yeah, so? And I'm like, well, I mean, like, can't build without steel. And he said, I don't give a bleep, build it. And he hung up, and I was like, okay, now what, but you get creative, right? And so then from Afghanistan, ended up doing a PhD at Stanford, did what they colloquially call an industrial PhD. So, I always joke, like if anything's going to make you dumb, it's 5 years of school, So I did 6 months off, 6 months on, and I did 6 months of consulting work, and I'd earn a little money and pay for the program that way. And so, but what I didn't realize at the time was again, everyone was like, hey, that's crazy. Like, why would you want to do that? Right. But in hindsight, what was happening was I'd go to the lab, tinker around with this technology, and then go try it in the field. And I'd be like, oh man, like here's all the ways that this was, a dumb idea. Here's all the ways that this is not going to work. And so I'd sort of take that knowledge, go back to the lab and fix those 6 things, right? And then 6 months later, I'd be back in the, And so basically, like, I think that really led to developing research that was very applied, like it had real world impact. And so through the program, like what I started to get interested in was space. So think of construction. Construction projects are empty.
Sure.
Think of any project, you literally drive down the highway, pick one, look at it, and it doesn't look like anything's happening, right? You might have like a pocket of work, but the rest of it's empty.
Yeah.
Now I was building the cruise ship terminal, right, in Amsterdam, and these guys are yelling, it's 6 weeks late, every day is 50,000 euros liquidated damages, right? So you can imagine like the mood in the room.
Yeah,
right.
It's pressure.
Your profit margin's gone. People are going to get fired. It's not a pleasant place. So as they're sort of yelling, I kind of needed to just step away. I got up, walked to the window. I'm looking outside, and this guy is basically saying, like, I can't work any faster. I can't work any faster. And as I look outside, I'm like, oh, what the heck? There's 100,000 square foot of empty space with 6 people in it.
Right.
And that's when it hit me. I was like, because like the funny thing was that at that point in time, even though I was 23 or 24, I'd already been on 15, 20 construction projects working, right? So that database was like, wait, like all the projects I've ever seen are empty. So I measured construction site space usage, right? And what I measured was how much space is on average used for construction, like what percentage? So we looked at a construction project. We split it into bays, 4 columns. Each 4 columns like the zone, right? And how many of those zones are occupied? Would you like to, or would the listeners like to hazard a guess at on average, how many bays or how many zones on a construction project are occupied?
Less than 2 or less.
It's a great guess. The answer is 3%.
Wow.
So like, exactly right. Yeah. So it's like, holy cow. Like if you look at asset utilizations in other fields, like top-notch factories, might get 70, 80%.
Yeah.
But you're looking at like 3%. So like that number kind of, to me, it hit me like a lead brick. It was like, hey, something's off, right? Like if the number was 40 or 30, right? But 3? So it was like, okay, so what's going on? So I started digging into it and I was like, well, increasing space usage should theoretically reduce construction duration, right?
Sure. Absolutely.
Right?
Yeah.
Cool. So I was like, okay, well, if I want to increase space usage, but then what sort of started to come out of it was, well, if you want to increase space usage, you want to, you could build column A and E and whatever, G, right?
Right.
Maybe you could build A and F and C, or, because you can't build all of the columns at the same time, right? So that kind of checkerboard pattern of which, so what I started realizing was like, there's like a lot of different sequences to this problem, right? So, because, which spaces are being occupied at what time. And so I was like, well, being at Stanford, being in Silicon Valley, I was like, well, maybe, let's use an algorithm. So we started tinkering around with algorithms, right? Built an algorithm. And then it was funny because I showed it to my professor and he said, have you validated it with the project manager? I was like, what? And he goes, yeah, have you validated it? Like your results look great, but have you actually gotten the guy that ran the project to say that they're great? So I remember saying like, hey, but that guy's in Amsterdam. And the response was, I don't care if he was on the moon, validated with the PM, right? Which I got to admit, like, getting that real world, and that's something that really Stanford does very well, I got to admit, getting that real world kind of, feedback. So I called those guys up, spent the afternoon with them, and that's what changed the whole game, because he was looking at the output of the algorithm and he was like, yeah, this is buildable. So, I jumped back in the plane, kind of sipping on a Heineken on the way back across the pond, as they say. And I was like, holy cow, this algorithm knows how to build. It doesn't know how to build very well, but it knows how to build. And that rabbit hole sort of led me to develop this whole sort of processor system. It's the world's first generative construction simulator. It's the ability to set up a rule set in a computer that governs your project, right? And then rebuild it as many times as you want.
Well, I think that's where you start to have an opening, right? Because if you keep looking at the way people have always looked at it, you're never going to see that crack. There's never going to be this opening, this bright light that says, oh, I can do generative computing to find a way to look at this project schedule. One of the things we had that was a massive breakthrough was seeing, we also noticed just the time that we worked. Right. If we looked at, we had cameras on every job site, and we're doing time lapses of them, and you'd watch, from 6 a.m. to 2 or 3 in the afternoon, maybe some up to 4, asses and elbows going, but then all of a sudden from 4 to 6 a.m. it's a ghost town.
Yep.
And the thought was, well, how do we change that one, right? How do we start to open up that one? Right. Yeah. And now it opens up a conversation like, could we have people work those hours? How could that work? And until you start to have that as a possibility, there's no chance you're ever going to see affect some sort of change. So now you see this possibility. You now start to look at it from a different lens. How does that grow? You got a project manager who verifies this. Hey, this is a great output. Now you've got a great process here. How do you start to really break down the pieces? Because there's 1,000 moving pieces on a job site. Yeah.
So I think that the trick, right, and there's kind of two ideas that, as you were talking, came to mind, right? One was what's interesting about it for any of the listeners, right, is that once you've solved it, and you look back at it, you're like, oh, it seems obvious. It seems super obvious, right? And that's the thing that I realized, like the difference between doing an unknown versus a known task, it's completely incomparable, right? Like with a known task, you put in X number of hours and you get X, Y output, 2X hours, 2Y output, right? With the unknown, it's like you have no idea, right? You're kind of blundering around in the dark. But to the listeners, it's like one of the things I started wondering about is like, hey, if this is an obvious thing that's like kind of sitting here, are there other obvious solutions to problems that literally are just in front of our noses, right? And so I did a little bit of Googling, and it turns out that yes, right? It's like I'm convinced that there's a bunch of like obvious problems out there that are valuable that you can solve by applying, but solving a problem is applying 15, 20,000 hours into it. Right. And so that's kind of what I started to realize, like there's a lot of innovation to be done out there if you can put the time into it. And a whole bunch of this stuff will seem obvious in hindsight. Like not all the obvious stuff has been done is the conclusion that I came to, I guess.
Well, right. I mean, a lot of times you look at a mess, and just because there's a lot of mess, you don't see the obvious ones, right? We get so overwhelmed. If I can't do any of it, I'm not doing any of it.
Yeah. There was like one example that I was looking at, which was fossils, right? And so fossils, like, they're like rocks that you take out of the ground, right? Yeah. So some lady somewhere, some researcher was drilling these fossils and noticed like a smell of burning hair. She's like, it's kind of odd. Like, could it be that, no. And then like, yeah, it turns out that fossils have collagen in them. And you can tell a lot by the type of collagen, right, that is in these fossils from what kind of animal it was and so on and so forth, right? So like something super obvious where, people have been handling fossils for, a few decades, right? Or many decades, right? And they didn't realize that there was collagen in them. Right? There's lots of these kind of really, I think, large discoveries yet to be made, right? If someone puts the time into it.
The thing I see that's the hardest though is it's hard when our people are heads down and they're just doing all day, right? Mm-hmm. In the construction world, you're always kind of behind. I've literally never been on a project in my entire career that we have more than enough time. We're always behind. There's always some force up against us, now kind of pushing us. There's that pressure. So I feel a lot of times there's not a lot of thinking. It's just a lot of doing, right? And I think sometimes it really does take an outside point of view to support this. Now, when I'm, receptive or not receptive, that's a whole nother question, but being able to stand back a little bit and look at it a little bit differently always seems to, there's another opportunity, right? Getting some outside help to come in and really assess All right, look, you guys aren't seeing this. You're too close to the fire. You're not seeing that you keep doing the same thing over and over and over again, and that's avoidable. We can make a couple of quick, easy changes. Here's the easy ones. Let's just do if there's 20 things you're doing wrong, let's get the 5 easy ones.
Right.
Right. And then it seems like the next 5 get a little bit less difficult to start to understand. So you start to see this. So you start to see the complexity of it and start to break it down in the parts and pieces. So the easy ones come first. So talk about, how does this continue to unwind for you? How does it, you're solving the problem in the lab, and you're going back in the field, and you're kind of testing it.
Yeah. The thing about innovation, right, is that, like, there's this book that I read called How to Fly a Horse, right? Best book in innovation that I, by far. And I've read a bunch of them. And this book explains what innovation really is. And most people think of innovation as, like, you've got to be some, like, super genius, right? And the super genius, like, crunches this massive problem in their head, and they have this aha moment, right? This huge light bulb goes off, and they're like, I got it, right? And this is it. That's the solution, right? Yeah, so both of those kind of, both parts of that statement are false, right? A, it doesn't need a super genius, and B, it's not an aha moment. So what the journey for me has literally been like, so you solve these 3 little issues, and you're like, okay, now I'm a little smarter, but those 3 things that I solved unlock the next 6 things. And you address thing number 1, and you try 4 different ways of doing it, and you solve it. Try thing number 2, you try 3 different ways of doing it, and you solve it. Thing number 3 and 4, and so on and so forth. And like, now that you solved those 6, you're like, you've unlocked the next layer of questions, right? And that is innovation. And that, like the truth is that here's the fallacy, is that people think that, like, I'm not succeeding because I'm not smart enough, or I'm not working on the right problem. No, it's just that the stuff that was, like, just easy, like, hey, I just had to solve 6 little problems and it took me a week and I'm done, are truly rare, right? That's right. It's meant to happen when there's, like, a shift in technology or something like that, right? But the stuff that, like, is an actual innovation, it's just, can you stick to that process for a year or 2 or 3, right? And get to a point where you solved it, right? And it's like Edison said, like, innovation is 99% perspiration, 1% inspiration. And it's totally true. Like, he spent a year in the lab trying to create a light bulb. And he had a gut sense or an intuition that putting current through a wire was going to create a light bulb. But the problem was, it burned everything. And so his thinking was, hey, I will try, like, that the solution is to find a material that won't burn. Right? Kind of makes sense.
That's right.
So he went through thousands, right, of materials.
That's right.
And somebody said to him, and I don't know if this is just legend, but the story goes that they said, hey, you failed 1,000 times. And his response was, no, I've just found 1,000 ways this won't work.
That's right.
And that's literally it. So at some point he was like, wait, instead of getting a material that won't burn, why don't I take the oxygen away? Why don't I encase it in glass and there's no oxygen in there? Boom. And that was it. That was the solution, right? But to get there, right, he had to go try all these different materials, right? And so that's kind of it. Like, the thing with innovation is that, like, it's little tiny stuff. And the thing that's happening in construction, right, is that we're living through the most exciting time in construction since arguably the pyramids, right?
Absolutely. It's absolutely the most amazing time. If you're not excited about this, you're not seeing it. The most dynamic time we've ever had, ever.
And it started, in my opinion, in about 2017. And what's happening in construction today is what happened to the manufacturing industry in the 80s. Construction is getting digitized, it's getting revolutionized, it's getting automated, it's getting optimized, like, all of that stuff's happening, and it's happening at the speed of light. Like, it's crazy. And there's a new ecosystem coming at us in construction, a completely new ecosystem. That ecosystem is going to be data-driven, right? That's the new currency of this ecosystem. And it's not a one person or one company game. And what's super, super exciting, by the way, is that VC, like, the VC money, that's venture capital money that's being pumped into construction, is what's enabling this. And what's really interesting is that, maybe 5 years ago, I was like, we're working on the really, cutting edge AI stuff, right? Like, I wouldn't want to be at a construction company working on like non-cutting edge stuff. What I then realized a couple of years later was like, hey, every single person in this field can be playing this cutting edge game.
Well, I think that you're hitting on a lot of great stuff there. For all of my career, it's this last couple of years, have I started to see this, BIM really changed the model. You can almost see the line and the curve up dramatically at BIM, right? You can almost see, where there is this huge influence at BIM where you start to look at the components, right? You're not just drawing a line on a piece of paper. Now that line now represents components. And now all the other technologies that have been developing for all the other parts of the world, the financial markets, the medical fields, communications, all of those technologies are now being applied. And it really needed to be able to look at, started with BIM, right? You really needed to be able to look at componentized construction so you could see the parts and pieces. And in fact, I think right now there are lots of groups that are running at gathering. I could not preach more on a daily basis how important data is, right? And over here, I get a lot of heck for man, that just seems like a lot to capture. I'm like, you understand, you can't tell today what data you're going to need in the future. Right now, try to collect as much of it as you can in every aspect that you can. And it feels daunting to some people, but I'm like, it's in the way that we practice. It's in the way that we practice our processes that will capture. It should not feel like this load that we have to carry. It should literally be in the way that we practice our projects.
That's exactly it. I mean, it's the thing that, like, again, right, if you're sitting in a construction company, right, you might think to yourself like, oh, well, I'm not working on the cutting edge stuff. The cutting edge stuff is too, difficult. Like, no, these startups are your R&D departments.
That's right.
You have now, literally, the game is that you have access to 3,000 R&D departments. And the name of the game, the general contractor of the future will be successful based on three things. How fast and can they identify these new technologies, right? How well can they evaluate them, and how well can they integrate them, right?
That's right.
That is it. Because if you are a construction company that is not leveraging whatever the heck it is, $1 billion of VC money that's going into it, then you are going to get outdone by somebody that is. And to answer your question, like to answer sort of, or to kind of riff off some of the stuff that you were saying, which is that as you go, like, this stuff is step by step, right? If you sit there and you're like, well, do I need to, build X, or do, like, what is it that I really need to do? So, I'll sit there and I'll say, okay, let's try, I know my business, and I know that the biggest problem we have is X, and the second biggest problem is Y. So what will solve X or Y? Let's take a look at it. And trust me, there's a startup somewhere that's working on it.
That's
right?
That's right.
So let's take a look at these startups. How many of them are actually, okay, let's figure out which are the best startups in this field. Yeah. And then take that and then implement it, right? And what you'll do is you'll implement and you'll learn, because the software, the technology is a tool. It's still, like you were saying, the processes around that tool that ultimately make it a success. The Army, there's still someone flying those F-16 jets, right? Or F-35s or whatever it is, right? And so, so now that you use the software, you're like, oh, the software enables these things that I wasn't able to do before, but I've learned that it's requiring me to tweak my process or what I'm doing to, input this data that I wasn't doing before, right? And so let's kind of sit down and rework, what processes in the company are and how they work, right? So that's sort of, roughly it.
Well, and there's that. I get this question all the time. Where do I start? Right, because you're a GC and you're used to doing it the caveman way. You carry heavy stuff over, you bang on it, and you make or not make money and all the stuff that goes with it. And then we're saying, oh, hey guys, there's another way of doing this, but it's going to require some upfront work which you've never done. Mm-hmm. But ultimately, you're trying to solve kind of three things that you want to. I mean, most companies are trying to solve three things, right?
Yep.
How do I make money?
Yep.
Right? How do I get it done on time? And, how do I give the customer what they want quality-wise? Right? I mean, so they're trying to solve those three things. And, they fail or not fail, but it's hard to understand. Once they're in it, it's too hard. They're failing or not, wherever they're at, there's not much they can do at that point. It's too late, right? And trying to recover in a failure is really difficult. And to say to them, hey, well, look, I can see what's happening. You keep messing up out here. It's not out here that's the problem. No matter how much out here work you do, you're not going to change this. It has to do with something you're doing back here, right? The process. And what I mean by that is something in the beginning of the process, before you started digging, before day one on the job site, you won or lost this job before you ever showed up there. Yeah. That's always. I've done this 1,000 times with hundreds of project managers throughout my career, and all these people that work for. And every time we have a failure in the project or a point that fails, you can go back always and find something that happened. Now there are some nuanced things that happen, or just real rare anomalies that happen, and they happen, right? In our business, it seems like rare anomalies are the norm. But to mitigate as many of those as possible, it really does take looking at the other side of this a lot different before you start moving anything.
The thing that's like interesting with our technology with Alice is that you can build a project 60 different ways before you build it, right? So that faith that you have and, hey, I can actually build it this way, is substantially higher because you have actually built it this way. You've actually simulated the project in that sort of construction method, right? And the other thing that I was thinking about is like, never underestimate the power of a motivated team, a small group of people that's motivated and isn't driven by ego so much, right? Which is like they can sit down and they can say, hey, what are the things that we learned? Let's try this again, and then do it. And then, hey, what are the things we learned? Let's try it again, right? And like a team like that, like one team in a company. And the reason I say this is that's what I was doing in the 6 months when I wasn't doing my PhD, when I was working, which is I'd go back to the Netherlands. And it's interesting. Like originally when we showed up there, we were like, hey, we got, BIM and scheduling. And I mean, these guys would roll their eyes, right? This was like a little village in the Netherlands. And they're like, you got to be kidding me. Like, this is all this Silicon Valley bullshit. You guys are all crazy. But, slowly, I found one guy that was willing to learn BIM. And that guy would start creating BIM models. Next thing you know, there's a project manager that was like, hey, I like working off of these BIM models, right? That's right. The scheduler was sort of like poking his head in the door and going, wait, can I do X or Y or Z, right? So, that's kind of like where we, how we did it. As you sort of go through, forward, like there are always people in any organization that are like willing to kind of push the envelope on innovation. And once you like the name of the game is can you get a critical mass of people? Yeah. Right. And it literally is that. Like once you get a critical mass of people, at some point it changes. And just like we were talking about, like, folks, yeah, originally everyone was like, oh, you guys are nuts. It's never going to work. But once it starts working, other folks, I want to be part of that, right? Why can't?
And that is the early adopters are brave, right? You got to give it to them. The early adopters that jump in with you and go down the belief path with you. And I just can't believe sometimes how much resistance there is in the market. And I can, because look, I'm the same guy who complains about his iPhone getting updated every day. So look, I get how there's resistance to change happens. But, when we saw BIM, right, all of a sudden we could, I remember back when we first started Revit and even for AutoCAD. Like when AutoCAD started, I'm like, oh my God, right? Look at this. It was just like another level that we could see axes and X and Y and, the different axes. You could really start to see a 3D model. And that was one level. And then you got to, where we start to look at really Revit, where the components of them. Now you're seeing the parts, right? You can see the parts, but then you're still, on one side, you're seeing every single part and you're breaking it down and every component. But you're still over on the scheduling side acting like I don't need to do that. Right? Yeah. And so you've got this amazing thing happening over here, but then you're still acting like this guessing factory over on the other side where you're not willing to go and do that same breakdown?
The answer is economics, right? Like most things.
That's right.
And the reason that like, here's the issue, right? The effort required to create detailed schedules that are useful is way too high. So we sat down and we actually calculated. So if you were to create a schedule that modeled crews working on components, crew A moves around to this zone, this zone works on steel, works on concrete, et cetera, like it could take you 2 years to create one single schedule. So people don't have that kind of time. So what you do is you cut it down. And so what's interesting about it is like, it's exactly the things that people said weren't possible. Like construction is too complicated. It can't be, boiled down the computer. Yes. If, right, or unless, right, if what you want to do is you want to have a button for every single type of nuanced construction, then you'll have like 10,000 buttons. So I agree. If you were going to solve it that way, it's not solvable. But if you boil down construction into the key core generalized scheduling constraints, that becomes possible.
How do you start to do that, right? So give me some examples of that. How are you taking the key components and decide that? What are the key components?
Yeah, so like if I had a dime for every time I heard this statement, right, which is like, oh, it can't be done, because I could see how it would. The first thing is it can't be done. Then you show it to them, and the next thing is, well, I see how it would work for that kind of project, but it wouldn't work for my super secret kind of project, right? But the truth of the matter is, it's like, it's construction, right? So the truth of the matter is that whatever project you are building, and here's the answer, the riddle, you are building elements, right? Or components.
That's right.
Those components are constrained by physics.
That's right.
And you need some tasks and some resources to build those elements.
Right. So elements, resources, and I would venture to say time, right? There's a time component, right? So you kind of got exactly that. And if you
elements that are constrained by physics, so some elements on top of each other, right? You don't want to build a roof before the foundation.
Right. That's right.
Okay. And those elements require tasks, and those tasks require resources. And a task has a duration in it. So that's where it comes in.
That's right.
But once when you think of it that way, every construction project in the world is kind of the same.
Exact same. Doghouse, skyscraper.
It's an element that is constrained by physics that needs tasks and resources to be built. And so that's the thing. Like, the truth is when people are like, oh, it can't be done. And I was like, you know what? I've built concrete columns on 4 continents. And I swear to God, there's one way to do it. I don't care if you're in Bangladesh or Beijing or, Chicago. You are going to put the rebar up. You will put a formwork around it. You're going to pour the concrete, wait for it to cure, dry, and then you're going to remove the formwork. There's one way to do it. So I thought to myself at the time, truthfully, what was kind of interesting is I thought, like, you know what? If nothing else, it can be done for concrete. Like, I know that, right? Turns out that it can be done for most things in the world.
So as you start to look at each of the components, right? So you get there's a limited number of components, or is there, or is it endless? Are components endless?
Yeah. So here's the other thing. So people are like, oh, it can't be done, right? You're like, okay, why not? Well, because think about it, right? For you to create a simulation or a schedule, right, that is useful, you'll need 500 to about 6,000 tasks. Kind of interesting, right? But literally, you can manage probably 80% of the projects in the world with 6,000 tasks or less. Right? We've seen projects where there's 100,000 tasks, nuclear facilities. We've seen projects with 20,000, so on and so forth. Like, most projects are about 6,000 tasks, 5,000, 3,000, 1,000. That's kind of it. Now, the issue is that people are like, oh, well, if you were to create a list of 6,000 tasks and then the constraint for each of those tasks, it's extremely time prohibitive.
Sure.
It can't be done.
Right.
You're like, yes, it can't be done if you approach it that way. But what if, right, I create a recipe, a template of 5 tasks to build a column, and that template gets copied 1,000 times for each of the 1,000 columns in my project.
Okay, so here you got 25 columns per floor. You got, 50 floors.
That's scalability.
Boom.
The scalability. So then what I'm trying to say is that boiling it down into the key constraints, right? And then enabling that scalability of putting in a few rules and they generate 3,000 tasks was the two tricks to solve these problems. And oftentimes, like I remember, like I read this thing, years ago, and it was like, somebody's like, hey, I've got this idea and I'm going to burning gas expands it. So what I'm going to do is I'm going to put the gas in a cylinder and I'm going to use that to power this horseless carriage. I was like, yeah, but the cylinder expands one way. How are you going to compress it? Can't be done. And I remember reading this little story and it's like, well, the answer is I'm going to have these cylinders in a circle. There's going to be these pistons and they're going to kind of circle around. Yeah, but if you do that, at one point the gas should be expanding. Another point, you got to be putting more fuel into it. And that's how it works. Well, yeah, but I'm going to have this 4-phase cycle when the gas is going to go out and the fuel is going to come in, et cetera. Solve it. Yeah, but then if you build a car, you can't start. You're going to need different gears. Can't be done. Well, I thought about it. I thought I got a gearbox, right? Oh, okay. Well, yeah, but the car won't be able to drive at night. Well, put lights in it. Yeah, but that's never going to work. I mean, what about when you're driving fast, right? The wind's going to, blow in your eyes. Well, I'll wear goggles or I'll put a windshield. Okay, but what if it rains? Then you're really hosed. Well, I'll invent these things called windshield wipers, right? That's literally how it works, right?
That's right.
The thing is that most people think that only applies to innovation only applies to building software or building, something in a lab or building, vaccines or innovation comes from some of the most successful companies in the world came from process innovation.
Well, that's right. Because when you're thinking about the engine, you're not thinking about the windshield wiper, right? Mm-hmm. But the guys who create the engine are the kind of people who create the windshield wiper because they realize that there's a problem and I'm here to solve it. And I'm not constrained by what is. I'm constrained by a solution. My desire is to find a solution to this problem which, by the way, didn't exist when I created the engine. Right? When I created the engine, there was no windshield.
Bingo. And it's if you're in a company, you're like, hey, how can we, be more innovative? How can we drive profit? How can we get more clients? And it's going to boil down to, okay, well, how are we doing business today? Right? A lot of companies, they don't know. We're like, I don't know. We're all smart. It's like, okay, well, maybe let's sit down and draw up a process map, right? You never follow it 100%. I get that. But okay, here's how we do business today. Mary gets this input and then hopefully she produces that output, right? And Jane gets, this input from Mary and produces hopefully that output. And here's the go, no-go decision. It's it, right? And so it's okay, what if we apply this technology to it, right? And that tweaks X, Y, Z, right? It's kind of the same thing, right? You're oh, but we tweaked the process this way and hey, here's where it broke down. That's right. Okay, don't panic. Let's see where it broke down. Can we fix that with a check or a document or something else? Right? This broke down, that broke down. It's kind of the same thing. And as you go through it, for you to create a new way of doing business, a new set of processes of the company, it's probably a year, right? But the truth is it's fun. Right? Because once you get that kind of core team of people that are sort of all on the same page of hey, we're actually trying something that hasn't been done. And if it's successful, here's all the benefits we expect to see. It's energizing. People like to do that. They get jazzed about it.
Well, I think what happens is it starts a way of being, right? I'll give you a little example. I'm 53 and I'm sitting in my living room last year, COVID, all the pandemic, feeling a little restless. I'm 53. Is this how I'm going to go through the rest of my life? Kind of, married man, kids, and, just kind of this routine I live, right? I get up, I turn on these lights, I do this, I make coffee, I take the dog. I have a route I live. It's a routine. And it's successful, right? Because I get my day done. I know where my keys are. I take out the garbage. My bills get paid. There's a system, but I don't know that was living life, right? I don't know that life was designed to be a routine. Now, effective in some respects, and my family knows where I'm at, and I don't wander off the place. So there's some value there. But then I noticed that there's another part of me that's really needs to be lit up, which was that adventure, right?
Yeah.
And as soon as I wanted to do a couple of things, and I said, look, I'm going to go. I went and tried. I said, I'm going to try flying airplanes. And just in the idea that I'm going to try flying airplanes, then I said, I'm going to start doing this podcast. And the podcaster. And then I started another venture. And I started, 4 or 5 other ventures. And what happened was it spears on a way of being. Like go back to challenging myself. And, I think that's what happens with people who start innovating. Like they start with, you get it and start to notice that whenever you're not innovating and you're feeling, all right, now it's time to go try something new. Go try on. If your company's in the doldrums and you feel like it's stuck, if you're an owner, I've owned this company for 25 years. And for 25 years, I've had to in fact, now I'm not the president of the company. I gave that up to somebody else because it was time to innovate with some new blood that I'd been for. So it took doing some things differently, and which, by the way, it's grown better now than ever before, right? The team that runs it today is great. Now I get to do some other things that are fun with the company. I get to spend time with people, but it takes stepping out and realizing, okay, let's try on something new. Even here, believe me, and letting go of being the president of a company, because I was when I introduced, hi, I'm Anthony Amunategui, I'm the president of this company. All right, that's there was a way I was, and not that I'm not valuable there, but I needed the company wasn't going to change if I kept doing what I was going to do, what I was doing. And we were really taking on women-owned company. My wife owns the company, and she became the president. And now we were able to hire differently. And, it was kind of hard to say we were a women-owned company and being run by a man, right? It didn't match, right? And some of that took a lot of, and by the way, giving that up, like stepping back and going, all right, I'm not going to be the president. Now what am I going to do? Am I going to twiddle my thumbs? Am I going to be valuable? Am I going to be important? It took a lot of, so like going back to your point, finding, being in that spot where you start to solve problems and start to innovate. It creates a long run of, it really starts a run of innovation.
Yeah, I definitely think that, right? I think that like Reinhold Messner, which is the first guy to summit Everest without oxygen, said, he said, what was it? There can be no adventure without death, right? Which I think is a little bit on the extreme side, but what he's really saying is kind of true, right? Which is like, there is no adventure without some risk of failure.
That's right.
And so, if you're doing something where there's no risk of failure, hey, I'm not saying it's you can't be risking everything all the time. Like you're a contributing member of society, right? You've got responsibilities, but if there's no risk of failing in any aspect of your life, then generally people will start to get bored.
So let's get back in it. So now you start to innovate. You get into this and you say, all right, I've got this. I see something different about construction. Start to notice there's tasks and this, how do you get to Alice, right? Because there's, look, 1,000, I have a death by 1,000 checklists and spreadsheets and forms in our business that, I've tried to process, make processes out of 1,000 different parts of it. And now you start with Alice. Where do you begin? How did you really start to get the bigger momentum, the total picture, not just one part of it, but the total picture of Alice's solution?
I really don't think that's how it works. Like I've got to admit to you, maybe embarrassingly, like there wasn't a moment where I was like, oh, I've got all the pieces. And like, I started working on space optimization. Space optimization got me to start using algorithms to optimize space. Somehow intuitively, I knew that if I optimize only space and nothing else, I'm just going to get crap.
That's right.
Like, okay, so I got to optimize space and precedence. That's when the guy that I showed it to was like, oh, that works. And I realized, hey, without I need resources like labor, equipment, materials, right? So I added equipment materials to it, right? And I was like, oh, it's growing, it's working. So then at that point, I was like, wait, if I have this little thing on the front end that generates the input file for the scheduler, right, called a planner.
That's right.
Right. So I had an idea of how that planner would work, right? And I remember like working with my colleagues and like, I remember at one point they asked me a question and I sort of smiled and like, you got to realize like I'm the guy. I've read like 3,000 papers, publications in construction scheduling, put together this team, et cetera, et cetera. And like, I kind of smiled and I said, I have led it this far, right? But at this point in time, you guys are way deeper in the weeds, way more aware of what the issues that need to get solved are than I am. And so respectfully, I'm not going to give you my opinion because I think yours is better than mine, right? And so we solved kind of the next piece of the puzzle, right? Like, I think what I'm trying to explain is that it's the thing that we solved today enabled the next layer of stuff and the next layer of stuff and the next layer of stuff. And at some point after we had like solved, 3 or 4 major layers is when it was like, wait, this thing could actually be this whole, beast that we didn't think about, right? But one of the best pieces of advice given to me, one of my dad's friends actually said, he said, if you ever look at, to achieve something, you need like 7 steps, right? To get to B, from A to B, you need 7 steps. Never wait until all 7 steps are clear to you. That's right. Just figure out how to get to step 1. And once you get to step 1, figure out how to get to step 2. And it's really, been a very, very useful thing in my life.
And that happens all day in construction. I'll get subs or a contractor or somebody say, hey, look, if I can't come get all of that work done, I'm not going to come and do any of it. And they'll say it's an electrician and they were missing a part or piece. And they're like, well, I've got this 40 hours to do, but I'm not going to come do any of it because I can't do all of it. I don't want to have to do it twice. But ultimately, they don't realize that get over there and get started. And then they realize the 40 hours they thought they had really becomes 60 hours they had. At least they got 35 of the 60 done. And they're moving forward. And by the way, they realized the parts they were waiting for, they needed some other parts. Right. Mm-hmm. And you don't get that until you start to go, like you said, start going down that path. So now you get a group of people and now how long has your group been working on? How many hours do you think you guys have invested in creating Alice?
I can tell you, something around 300,000.
300,000 hours in putting it together. Now, for folks out there that haven't seen Alice, I really want them to get an understanding of how Alice works. Let's kind of go down the components of how, all right, so really paint the picture of how, when I'm talking to Alice, hey, Alice, I need to reschedule, put the schedule together. Let's talk about how that happens.
So what is Alice, right? It's probably a good thing to put at the beginning of it, but let me start. What is Alice? What is Alice? So Alice is a generative construction simulator. And so for folks that are unaware of what generative construction is, don't worry, you will be experts in about 30 seconds. Generative construction, the way I explain it is by using an example of parametric design. So don't worry, all the dots will connect in literally 30 seconds. Parametric design. What is parametric design? Let's assume that you want to draw a cylinder. So today you draw kind of 2 lines in a plane. Let's say you want a smaller cylinder. You redraw it. A bigger cylinder. You got to redraw the cylinder every time, right? If the tool's parametric, you got a height diameter. You change the parameter, right? And the tool redraws your object. Does that make sense?
That's right.
In our field, we call parametric design BIM.
That's right.
That's what it is. You can change the height of the columns and, the 3D model updates, the 2Ds update, all that kind of stuff updates, right? BIM is fundamentally 2 technologies. It's object-oriented. It knows it's a column made of concrete on the 3rd floor, and it's parametric. So that's parametric design. And we've lately seen the advent of generative design. What does that mean? It simply means I don't want to change the parameters one by one. I want you, the computer, to change them for me. Go through all the options from 1 to 10,000 and give me the best solution with the greatest rentable area, the greatest power output from my engine, and so on and so on. So that's what generative design is. It has never been done in construction, and that's what Alice is. Alice is a generative construction simulator. What we do with Alice is we can generate 60, 70 different ways of building a project almost instantaneously. You can literally say, add a crane, rebuild it. Add a crew, rebuild it. Try overtime, rebuild it. Like resimulate. Literally, you will type in, create a new simulation run, you'll add a crane to the parameters, hit resimulate, and it will boom. Like you've got 1 crane, it builds building A, then building B. You add 2 cranes, buildings A and B go up at the same time.
That's
right. So, and for each of the solutions, it will give you a generated schedule, a 4D, and all that kind of stuff, right? The way we did it, right, is that we we realized, or I realized, we realized that you have to separate planning from scheduling.
Just to make the distinction, planning is
the rules that govern your construction project.
So rules. I can't. You can't put. You got to put footings first before foundations. Foundations before.
That's one rule. That is the physics.
Got it. So it's got to be physics.
Well, that's one. There's three rules. Okay. The first rule is physics. Which elements sit on top of which elements?
Got it.
Then I need to build it in that order, right? Rule number two is grouping and splitting. So in construction, you don't tend to manage things column by column. I'm going to build all the columns on the third floor in one go. It's one task. Rule number three is what we call recipes. And recipes are what tasks and what resources do you need to build this element. So those are the rules. Notice, though, that the big difference is I don't figure out how to build a whole project. That's the scheduling. We stopped referring to scheduling, we call it simulating, right? But I've told the software, here's how you build a column. Apply that to all the columns. Here's how you build a slab. Apply that to all the slabs. Here's how you build a foundation. Apply that to all the foundations. Here's the resources I have available. That's it. I don't get into how those resources are getting shuffled to the tasks, how they're moving around the project, and which are available and not available. Like, that's the crunching part, the number crunching. Let the computer do that. Basically, right, the way it works is you set up the rule set, you send it to the scheduler or the simulator, I could say, and that crunches it for you and starts to generate solutions. And you can then start exploring, right? And that's kind of like one of the cool things, right, which is there isn't one way to build a project. There's lots of ways to do it, right? You could build it with one crane, two cranes, overtime, no overtime, 12 steel crews, 14 steel crews, and so on and so forth. And so with this solution, right, you can start generating and exploring the most optimal way to build something. And what you'll figure out is that, on average, we can save about 17% on the duration, construction duration, and about 13% on labor and equipment costs.
Got it. So by looking at being able to look at each of the components and figuring them out, going back and regenerating the schedule, the model. Now you can start to see, places where you can save. Now, give me some ideas on how that works, real quick.
For example, what you'll say is, let me run this with 4 steel crews, one crane, no overtime, 3 carpenter crews, and whatever it is.
Okay.
You run it, and it says, okay, your duration is, call it 270 days. I'm like, okay, great. What happens if I add a crane? And it will rerun it, and it'll say your duration is 260. So I'm like, well, that doesn't make any sense. Why is it not a big, I didn't expect a bigger improvement, right? And you dig into it. And here's what's funny, right? It's like, what you think is you build belief in an AI system when you change a parameter and you see the effect that you expect. It turns out that there is more belief that you gain when you change the parameter, you see an effect that you didn't expect, and upon investigation realize that it's correct because it was right when you were wrong.
That's right.
That crane example is one that I'm familiar with because it happened to us. And so everyone's like, what the heck? It doesn't work. We're like, well, hold on. We looked at it and it's like, oh, we have an extra crane, but there's not enough steel that we can supply. Right? So that's the thing that, like, a lot of folks ask us, like, what is a critical path? What are the critical tasks? Our entire industry is like hell-bent on this way of thinking. With Alice, what you can start asking is, well, do you want to know the critical path? Which we can give you.
Sure. But
what about the critical resources? What about the critical calendars? Right. What about the critical relationships, right? Because all of that kind of stuff, it's like a cocktail. It's like you're cooking a meal. It's all interacts with each other, right? And so, like, what's really interesting about it is that, like, you'll start to see that oftentimes you get the biggest bang for your buck when you do like 2 or 3 changes at the same time, right? If you add a crane, increase the steel supply, rate, and, for example, tweak overtime for steel crews, right? Then boom, that's when you suddenly see that big, 20%, 15%, jump.
And I think that's the thing that helps, is because being able to look at the factors of the recipes, therein lies those spots where I can kind of, it's such a big thought to do by myself. It would take you forever to get there. Just you could have them, but just to be able to get there, having a computer program that can go through and have all of those thoughts for me, dramatically. I love that. I mean, and that's really where the differentiator is for Alice, is that it's having those thousands and thousands of related thoughts, relationship, the components, the time, all those aspects are happening in seconds rather than what would take me, hours or weeks to do.
Years, we think, actually.
Yeah. Right. I'm trying to get my ego.
Yeah, what's interesting about Anthony is that, like, what we're seeing with AI, and it's a pattern that we noticed at Stanford, is that we see that over and over again, right? What you'll notice is that what AI does, or technology does, is it becomes the entity that does the crunching, and the human becomes the entity that sets up what needs to be crunched and interprets the results. And a little while down the line, a new AI comes along, and that piece of the puzzle is now what gets crunched. And then the human, again, is what sets that piece of the puzzle up and interprets those results, right? So what's interesting with Alice is, like, Alice will quickly tell you, for example, that if you had, here's a good example, right? So let's assume that you had 4 steel crews and the duration was 270. And then you look at the graph, and one of the things that you'll see with Alice is, like, well, that 4th crew isn't really used, right? Like, it's,
Right.
Now, 4th crew is kind of sitting around, like they're used on these 2 weeks, and other than that, they're sitting around.
Right.
So you'll say, well, let me rerun it. You'll rerun the simulation with 3 crews, and the duration might be 275, 5 days slower. So you're like, whatever. I don't really care. Let's do that. But what I'm saying is, somebody on the job might say, yeah, but I want that 4th crew, right? Because if I have 3 and one of them doesn't show up, I get really dinged.
That's right.
That 4th crew is my buffer. Now you're starting to see how the interplay. We've started to refer to it not as AI, but IA, intelligence augmentation.
Well, I think there's where it starts. The model starts getting smarter and smarter. Like I said, you're now at this level model. Now the next level model, it starts becoming. You start looking at ratings of people, their absentee, time of year. You start to really look at the human as a component, right? And start to measure, get smarter at measuring their effect. In other words, are they 5-star, 4-star, 3-star employees, and for their deliverable and their consistency, and that starts to get measured, and then that, I think your model starts getting even smarter. Great. Look, if I've got all 5-star crew, great. Then they rarely have a missing component or a day off or miss a schedule. Then maybe I can go to that 3 crews. But if I'm looking at, hey, I've got 3 stars or 3, I can't risk the rest of the schedule on that. I can't lower that. So I think that's where the next level really continues to get smarter and smarter and grow more and more intelligent every single time.
Yeah. I mean, that's the thing about algorithms, right? They're pretty stupid to start with, but the thing about them is that you teach them something, they don't even forget it.
That's right.
You know, something else, you teach them, like, every time you teach it, that's now its baseline dumbness. But you do that over 300,000 hours, right? It starts to get pretty smart. Well,
I got to tell you, you guys are your group is breaking barriers. I mean, it's revolutionary. It's fun to watch. What you're doing is, it makes me giggle inside, and with lots of joy for the work that you're doing. Your entire group is breaking. Breaking these boundaries, and at Alice Technologies, as you guys continue to break this. And by the way, I love having this conversation about how you built it. I think the audience is getting a really good sense for your, how you've built this and where you've gone with it. As you continue to make these breakthroughs, I want our audience to really get involved. By the way, guys, we're going to put a link down below. Please go to alicetechnologies.com or it's alicetechnologies.com and hit the homepage there, and there's all kinds of great information about Alice and demos and practices on there. I want to make sure that everybody, please go do that right now. Right after this, I'll put the link down below. Take a second, go check it out, because it's worth you're thinking about it. Someone once had me read the book Life 3.0. Right, it was about really getting into AI, and it changed my life. Well, I'm going to tell you guys, this is the kind of thing to really look at because it's going to change your companies, right? All you guys out there, the subcontractors and contractor world, wherever you are in our construction world or development world, you got to start looking at this type of technology to start really running your programs. It takes what we used to do with all of these forms, and it puts it in a whole nother light. René, you and your group you're blowing the socks off of it.
That's really great to hear, Anthony. Thanks so much for saying that. It's a labor of love. Like, really love what we do, and we think it's gonna change how the world builds. Right?
It is. It is already. You guys are doing that. If folks want to get a hold of you, get a hold of René, where do they get a hold of you?
Shoot me an email, René@alicetechnologies.com.
All right, got it. So that's RENE at Alice Technologies, ALICE technologies.com. You get a hold of René, and I mean, trust me, the conversations I had pre-game were amazing. And by the way, we'll have you guys on again. I love what you're doing. I want to continue to unravel what it takes to put this together. I know it's a big conversation to have, and our audience loves this stuff. I love it. Just love what you're doing and what you're up to. So kudos to you and all your folks over there.
Such a pleasure to be here, Anthony. Thanks so much, and I hope your listeners have a great day, and you too.
Thanks. Hey, if you guys liked this podcast with René and I, please just take a second right now and like this. And if you really liked it, please subscribe. That's how we know that we're heading the right direction. If you got some comments or something you want about it, please put that down there. It helps us getting your feedback. It really does help our entire crew learn how to do this better and get smarter at it. And we're grateful for all you listeners. So thanks for being here, and we'll look forward to doing this again.
Awesome. Thanks so much.
Thanks for joining us. My name is Anthony Amunategui, always looking for people to bring insight into the industry, finding ways to inspire people to have amazing careers in the development world. If you liked our podcast, make sure you hit the subscribe button down below. If you really liked our podcast, make sure you hit the little bell. Thanks again for listening. Please share it with your friends.